video, I want you guys to focus on taking good notes, watching something again that you either missed or did not understand, and make sure you write down any questions you have during the video and ask them to me in class when we come back from break. Today we are going to discuss graphing exponential growth functions. This section goes along with section 7.1 in your textbook. Your learning target is I can graph and use exponential growth and decay functions. The decay part comes in with section 7.2. We'll talk about that later. So by the end of this lesson, you should be able to say you can graph and use exponential growth functions. An exponential function has a little bit different form than we're used to. Instead of the variable being a part of the actual term, your variable is now your exponent. So it has the form y equals ab to the x power. A is not allowed to be 0 because then the whole thing is 0. And your base b, the number that has the exponent x, has to be a positive number bigger than 1. Okay, so when we get into exponential decay, that's when you have a negative b. But today, for exponential growth, b has to be bigger than 1. If a is bigger than 0, so as long as your number is not 0, and b is bigger than 1, then we have an exponential growth function. We are also going to call b, our base, the growth factor. Just like all of our other functions, f of x equals b to the x power has a parent graph. That means that's the starting graph, and all of our other graphs that we're going to do that are similar to this growth function are kind of based off of this graph. There's a lot of stuff going on here. Remember that this is also in your textbook. Okay? The parent function of f of x equals b to the x, remember b has to be positive, otherwise it's a decay function, we're not doing that yet, is kind of a slow curve going up to the right there. The parent function passes between 2 points. To figure those out, we would actually plug in 0 and 1 in for x, and then we would get the y value. If we plug 0 into the parent function, you actually end up with 1. So the parent graph goes through the points 0, 1, and 1, b. And that might look familiar to you. b is also your base. So it's going to go through 0, 1, and then the point 1, and the y would be your b value. Okay? Remember, your b has to be greater than 1. Otherwise, different type of function. New word that we're dealing with here today is the word asymptote. An asymptote is a part on a graph, a line on a graph that your function will get closer and closer and closer but never touch. For the parent function of f of x equals b to the x power, you have an asymptote at the x-axis. It's going to get closer and closer and closer, but it's never going to touch or cross the x-axis. For these types of functions, you will always have an asymptote. It might move a little bit, but you will have an asymptote. Okay, and here's the definition down here. A line the graph approaches but never touches. You might want to write that down in your notes. That will come up later. Now let's go through an example. Our first example involves graphing one of these exponential growth functions. And I know it's a growth function because my b value is 2. And that is definitely bigger than 1. So we have a growth function there. To graph this, it's the same process you guys have used to graph all of your other functions. We're going to make an xy table and plug each x value into our function to get a y. Okay, so let's start with y here. We are going to plug negative 2 in for x. We'll get 2 to the negative second. And you guys should remember your exponent rules. We have a negative exponent that has to move to the bottom. It becomes a fraction. So we get 1 over 2 squared. or 1/4. So let's graph that right away. There we go. I'm going to draw in my XY axis. And let's plot our first point. -2, 1/4, or 0.25. You can definitely use your calculator for that one. So there's -2, probably right about there. You're going to have to do some estimating here. Next one. Let's plug in, I'm going to use some color here. Let's plug in -1 in for x. We'll get 2 to the -1. That is the same, which you guys probably know that, as you should, 1/2, or 1/2, right? So let's plug in our next one. We have the point -1, right about there, 1/2. That'll be about halfway between there. Okay, remember we're kind of estimating for those, and that's okay. We'll have some other more exact points to kind of make up for that. Now let's plug in 0. We'll get 2 to the 0. Looks like a 6, that's a 0. 2 to the 0, you can find that on your calculator easy enough, but you'll get 1. Okay? So our next point is 0, 1. And that should look familiar to you guys. That's one of the properties of this parent, or this exponential growth function, is they will go through the point 0, 1, unless there's some transitions, and we'll get into that later. Next, we're going to plug in 2 to the first, which is just 2, so we're going to graph the point 1, 2, right about there. And you guys might remember the other point these exponential functions go through is 1, and then your b value. And here our b value is 2. Okay, last one, 2 squared is 4. There's 2, goes up to 4 there, and we're going to put a dot. So our points are plotted, we have accurate values, we are almost done. Step 3, we're going to go from left to right and draw a smooth curve through those points. Remember, it has to be just above the x-axis, because the x-axis is an asymptote, meaning it's a line that your graph will get closer and closer to, but will never touch.